Why does it say to find the approximate area? Tar, ding, ding, ding. Because you're going to have to use trigonometry because that is a pentagon, and a pentagon is not special. It's not 30, 60, 90. It's not 45, 45, 90. Very good. So you're really just going to be finding the area of one pentagon and the area of 5 triangles. It's been a while, huh? Had that long weekend. We will go over this warm-up, and then we're going to do lots of practice problems, and then you can work on your review sheet. Okay, Kwan is asking about the assessment because tomorrow is an assessment and Wednesday is your test. So your assessment's going to be over, it's called Area of Irregular Regions. So remember page 2 of your circles homework where it had all those circles with like a hexagon inside or a trapezoid with a circle inside, and there were shaded regions. That's what your assessment's over, shaded regions. This warm-up could be on your assessment. That's like the area of an irregular region. It's not just a pentagon. It's multiple shapes. It's called a composite figure, actually. So it's going to be finding the area of composite figures. That's what your assessment's over. Whereas your test is a little bit more basic. It's like find the area of this circle, find the area of this triangle, that kind of thing. Okay, so Tar is asking what's the 360 divided by 2n thing? Why do we need that? Where do we use it? I'm confused. So that's okay. When you're finding the area of a pentagon, you need an apothem. In order to find that apothem, you're going to have to use trig. So this is 2 right here. I'm going to take this triangle and I'm going to draw it larger. This is 2. This is your apothem, and this is your radius. You cannot find the missing sides right now because this is not 30, 60, 90, and it's not 45, 45, 90. So, I personally do 360. There's 360 degrees in a circle, and then I divide it by how many triangles. If I were to draw triangles all over this pentagon, I would end up drawing 10 triangles because there's 2 triangles per side. So that's easy to me, 360 divided by 10, and I have now found that angle. That's a 36-degree angle. If you want to find the other angle, you can. You don't need to find both. Yes, Anna? So now we're going to find the apothem. We don't need the radius, we only need the apothem. So we've got opposite, and we've got adjacent. So this is tan. So tangent of 36 equals 2 over x. I'll just call it x. Opposite over adjacent. So now we are going to do denominator divide. Type the 2 first. 2 divided by tan 36. Make sure you're in degree mode. I'm getting that the apothem is 2.75. The more decimal places you hold on to, the more exact your answer is going to be, or you can just keep it in your calculator. So that's the apothem. Let's multiply it by the perimeter. The perimeter is what? 4 times 5, 20. So 2.75 times 20 divided by 2. So we're going to add the area of the pentagon plus the area of 5 triangles. 5t, I'll put 5t. So we already found the area of the pentagon. It's 27.527. We'll just do 27.5. So now we need to find the area of those triangles. Now, we have 4 and we have 7, but that's not the base and the height, unfortunately. The base is 4. The sides are 7. So we need to find our height. So we're going to do 7 squared minus 2 squared. So the height is the square root of 45. No need to reduce this because we're going to end up turning it into a decimal anyways. Yes, it is always okay to keep all the decimals, yeah. Okay, ready? Base is 4 times the height, square root of 45, divided by 2. So I'm getting that the area of one triangle is 13.4. But there's 5 of them, so I'm going to do times 5. 67.08. So 67.1 plus 27.5. And the final answer to this problem, 94.58. It didn't tell us what to round to, so it could be 94.58 or 94.6. An equilateral triangle has a perimeter of 12 root 3. What is the area of the triangle? Okay, what'd you get? What's your answer? Okay, let's go over it. So, we have an equilateral triangle and we know the perimeter. When we know the perimeter, that means we know each of the sides. So we know that each side is 4 root 3. We want to find the area. The area of a triangle, we need a base and we need a height. We're going to multiply them and divide by 2. The base is obviously 4 root 3. So now we need the height of this triangle. Or remember this, side squared root 3 over 4. You could also use that formula. I'm going to go with this one just in case you didn't memorize the other one. So in this 30, 60, 90 triangle, this is 2 root 3. 2 root 3 is across from 30. So what goes across from 60? 2 root 3 root 3. So what? 2 times 3? 6 is our height. Base times height divided by 2. So final answer, 12 root 3. Good job. No problem. Next one, find the area of a 45, 45, 90 triangle with a hypotenuse of 40. Ooh, you're all getting the same thing. That's good. So, 45, 45, 90. Isosceles, right and isosceles. So if the hypotenuse is 40, we automatically know that these are 20 root 2. Where did 20 root 2 come from? We took 40 and we divided it by root 2 and rationalized that denominator. 40 root 2 over 2, which is 20 root 2. This is our base and this is our height. It doesn't matter which is which, they're interchangeable. So it's base times height divided by 2. 20 times 20 is 400. And then what's cool about this is root 2 times root 2 is 2. And it's actually going to cancel with the denominator. So you may have solved that a different way, but either way you're going to get 400. Final answer, 400. Next problem, find the area of a regular pentagon with side length 8. We did this in the warm-up, so let's see if you can do it again by yourself. Okay, a regular pentagon. As good as it's going to get for Miss Tanton. Okay, so we know that these sides are 8. And since we already did this in the warm-up, we are lucky. This is 4. We know that this is a 36-degree angle because we did the degrees in a circle divided by double the number of sides. Because if you were to go all the way around, you would end up drawing 10 triangles. So that angle is a 36-degree angle. If you want to do n minus 2 times 180 divided by double the number of sides, you can do that as well, since that angle got bisected. All right, so we need the apothem. We need A. So it's tan again. Tan of 36 equals opposite over adjacent. Denominator divide. So the apothem is 4 divided by tan 36. That's the apothem. Then we'll multiply it by times the perimeter and divide it by 2. 4 divided by tan 36 is 5.5. That's not bad. Okay, so we're going to do times. What's the perimeter? 40, right? 8 times 5. And then never forget to divide by 2. Y'all did good. Final answer to this problem would be 110 point, I don't know what it tells us to round to. And y'all were good about putting your units last time when I didn't put my units. Good job. So really just 110. 0.11 or 0.1. It depends on what the problem tells you to round to. Very good. Not so bad after all, right? Find the area of the kite. Do you remember this formula? Remember on your formula chart, you get to use your formula chart. The formula for kite is the same as the formula for rhombus. So even though kite is not listed, it's the same as the one for rhombus. Very nice, guys. So we're in luck. We had a 45, 45, 90 triangle waiting for us. So we know the rule is x, x, x root 2. We also know in a kite that this is a line of symmetry. So this is 15 as well. Diagonal 1 would be 15 plus 15 times diagonal 2. So that would be 27. Diagonal 1 times diagonal 2 divided by 2. Final answer, 405. Not bad. So just remember that the formula for a kite is the same as the formula for a rhombus. Whoa, not drawn to scale. No, actually really poorly not drawn to scale. Yeah, sorry about that. A square is circumscribed about a circle with a radius of 28. Find the area of the square. So remember, when you're working these problems, you can cross this word out and you can write outside. So that's saying a square is outside a circle. So that's really important, because the circle does not hit the square at the vertice. The circle is going to hit the square at the sides. The circle has a radius of 28. So when the circle is on the inside, the radius of the circle is the apothem of the polygon. That's when the circle's on the inside. Now, when the circle's on the outside, who cares? The radius is the radius, nothing special. But when the circle's on the inside, the radius of the circle is the apothem of the polygon. Find the area of a square. Now it's easy. Once you've drawn the picture and you know that 28 is really the apothem, not the radius, it's very easy to find the area. So, what is the side? And then the area would equal side squared. Right? Very large number. What'd you get? I'm hoping that you didn't do apothem times perimeter divided by 2. I actually don't ever use that formula on a square. I always do side squared because the side is so easy to find. Okay, good. A square with side length 10 is inscribed in a circle. Find the area of the circle. Totally different problem. Let's get a picture going. So we have our circle. The square is inside the circle. Oh, mine's going to be a rectangle. Sorry. Mine looks a little more rectangular than it needs to. The side of the square is 10. To find the area of a circle, we need a radius. So you're going to need to draw yourself a radius. Then you can draw the apothem right here. This is 5, 5, 5 root 2. How do you find the area of a circle? Pi r squared. So pi times, let's see, 5 squared is 25. Square root of 2 squared is 2. So the final answer to this problem is 50 pi. Good. 50 pi. This was the last lesson that we taught. It might have been the one that you've practiced with the least. What's the ratio of their areas? I gave you the sides, and I want the ratio of the areas. Go. So what I recommend on this problem is you can write the ratio, but then I would reduce it, and then I would square it. Why are we squaring it? Because squaring it gets us from 1D to 2D. It gets us from side to area. Are we actually finding the area of these triangles? Absolutely not finding the area of these triangles. We're just finding the ratio of the areas. So I would start like this. You can also write 60 to 14 since it didn't specify the order. 7 to 30. And now we want to go from 1D to 2D. So we want to square both of our numbers. And that would be the simplified version of the ratio of their areas. Now, if you went ahead and squared 14 and 60, that's fine. Just make sure you reduce their ratio when you're done. Make sure you reduce it. Okay, good. What's the area of a hexagon with a radius of 20 root 3? So, hexagon. Good enough. Okay. The radius is 20 root 3. We know that we have a 30, 60, 90 triangle. A lot of times I take that triangle out and I draw it larger so I can see what's going on. 20 root 3 is across from 90. In a hexagon, we know that the 60 goes here because 120 divided by 2 is 60. We need the apothem and we need the perimeter. So we need to find both missing sides. We know we take this one and we divide it by 2 to find what's across from 30. So this would be 10 root 3 across from 30. And then we multiply this by root 3 to find what goes across from 60. So it'd be 10 root 3 root 3. So that would be 30. So the apothem is 30. What's the perimeter? Remember that this right here is only half of your side. So each side, if I go back to my picture, would be 20 root 3. And there's 6 sides. So apothem times perimeter divided by 2. Yep, 1800 root 3. A large area here. And we don't have units. Okay, let's keep going. Oh, that's all actually.